QR codes on this bridge. So we take all of that data and we process it into a digital twin of the bridge. And then we take that digital twin, we do a pre-inspection in the office. So our engineers spend some time to document as much of the inspection information before we ever go out in the field right on the digital twin. And that saves a lot of time and also improves the quality. And then we take all that digital twins with all the inspection information in there, and they go out in the field with tablet computers and record everything in the field that maybe they didn't get as part of the pre-inspection, or stuff that you couldn't see, or they're just confirming that it's the correct information. And then we're moving into the rehab design and plans portion, and we'll also carry all of these deliverables and digital twins into the construction phase of the project. So that first step we talked about, the very first thing we did was go out and collect the data. For this bridge, we had, I think, 9 of these arch spans, so it's a pretty large bridge. And we used Skydio drones, and we used 3D scan to collect all the data. And that was a huge time savings and improved the quality by quite a bit, because it kind of takes the art out of collecting data on a complex bridge like this. It took us, I think, about a week to collect all of the data, and with 1 or 2 people in the field at a time. And the thing that was impactful to me was just, compared to doing this same thing, 8 or 10 years ago, it now just becomes boring, because we're literally just waiting for the drone to finish collecting the data, whereas before we were nervous about flying and worried about hitting the bridge and those kinds of things. And the way we did this bridge, and I know a lot of others do the same thing with the 3D scan, is we set the ceiling at the bridge deck level, and we do a 3D scan of everything underneath the bridge deck, so that the drone isn't flying over traffic or near traffic. And then we do a 2D scan of the top of the bridge and the bridge deck, and combine all that later. I think the only incident we had was we had a homeless person throwing rocks at the drone, but luckily he wasn't very accurate. And it was kind of funny, because he was pretty mad when he saw the drone, but he came up and he saw me, and he said, "What are you doing?" And I said, "I'm doing a bridge inspection." And he said, "Well, how does it look?" And I said, "Good." And he said, "Good." And he walked off. And that was the end of our interaction. So again, once we collect all of that data, we post-processed it. We used the Bentley context capture, or our iTwin modeler, to model all of the spans. And what we did was we modeled each span individually, and then when we uploaded them onto the iTwin experience, we can just check off each individual span to see it. And if we check them all off, we can bring the whole bridge up. And the bridge turned out great. It's kind of interesting just how the older bridges with much more defects are so much easier to model, because there's so much more for the photogrammetry to kind of look at, and more differentiation. And we flew the bridge at about 12 to 15 feet, so that we could get enough inspection information and see really small cracks, and use AI, which we'll show a little bit later. And I think in total we had about 57,000 images of the bridge that we processed. So again, once we process it, we do all this pre-inspection in the office. So our engineers sit down at their desks, and they just start going through the models, finding the spalls and different defects. We run AI so that they can use that as well. And so it's much easier to draw a spall or a DLAM in the office on your computer than it is to do it in the field. It's more comfortable, It's safer. And we estimated that we could put about 80% of the inspection information on the model before we ever went in the field. But then, then we take that information, we go in the field. We're not trying to eliminate the field work or eliminate that part of the process, because that's still a very important part. We still want to get our hands on things and hammer things and do those checks. But we created this custom inspection form in the iTwin experience, and we have all of our normal inspection information in there, who the inspector was, the date, the description of the inspection, everything that we would normally take down, but we did it in the digital twin environment. And this is just a screenshot from the iTwin experience, and on the very left is our inspection information. In the middle is the actual model or the digital twin, and then on the right is our photographs, so we can click anywhere on the model and see those different photos of that same location, just to verify while we're doing the pre-inspection that things are correct. And the thing that really, to me, is impactful is that we're adding a level of quality control to the inspection that we really don't have a way to do with traditional methods. So in a traditional inspection, an inspector goes out there, they see something, they sketch it, they maybe take a few photographs, but there's really no way to do a real quality control without having a whole nother inspection crew redo the inspection and compare the two. But in this method, we can use the digital twin to do a quality control. So one of our steps in the inspection form is we add a check. So every defect that we document, we have another engineer assigned to check that defect and verify that it's correct. And using the digital twin, I mean, we theoretically could even find things that maybe got missed in the field as well. And Jen's going to talk about the AI portion.
I'm not a bridge inspector, so I'll talk about the AI. So here is what the AI came up with. So you can run, this one was run into iTwin Capture Modeler, but you can also run it within the iTwin experience. And not only do you have the AI detection, but you have it projected on the 3D, right? So you have its entire length, it's not cut within the image. And because you have it within your 3D model, you also have its properties. It's not only an image that is without any measurements, right? So with a 3D model, for each crack, you can have its width and its length. I know Mr. Callahan showed it this morning. We do not have depth yet, as he talked about earlier. So now that you have automatic width and length, you can have automatic severity scale as well. And now it's much more easier to do the reporting of all these cracks that most of you who are bridge inspectors know how tedious it can be to really document each one, and now the computer does it for you. Again, we're not replacing the inspectors, we're just helping the inspector go much faster in their process and documenting and reporting these cracks. And talking about reporting, Barrett is going to continue.
So another feature that's built into the Bentley portion is this issue resolution service. And we talked about the inspection form that we had before, so everything that we're inputting is data that then we can analyze through this issue resolution service. I know it's probably hard to see, but like we can look at different properties and graph them and look at what kinds of, what is our share of the different kinds of defects. In the radial chart, it's just showing how many defects each inspector can find, so we can fire people that didn't find very many, if knowing they're working too slow. But there's just a million different ways you can look at this data, and you can kind of do it on the fly. We've done it in meetings, and people ask questions, and so instead of saying we're going to go back and try to do those calculations, we can just immediately pull that up, and then this also becomes another way to do quality control because we can check, how many of the defects are still open and how many have been checked and those kinds of things.
So now you have this data, this digital twin within your platform where we have multiple information. You have your digital twin, you have your issue resolutions, you have all your defects that you noted, your issues, and all in this platform, right? I know Mike was showing, I think Carlos, I don't know if you're, yeah, Carlos, you're there. You were also showing how you can have over time. So unfortunately, we didn't have the drone captures from 1926, so we didn't have the construction models. But as we go on in time, like in 2 years, in 4 years, you're going to be able to have that digital twin and see how that bridge evolves over time, right? But now we did it for one bridge. What if we do it for all the other bridges? And within one platform, you'll have all your digital twins of your bridges, right? Making it even more centralized and having all your data in this place. But you're going to tell me, what about my current asset management or inspection management data, right? And this is where you can streamline all your data coming from asset-wise inspection or superload. So asset-wise inspection is your inspection data management software from Bentley. And then the superload is your permit for trucking permit software. So not only do you have your inspections and the condition of all your assets, but also the analytics of how much traffic you have going on there. So now you have this holistic view of not only your digital twin asset, not only one, all your digital twins, but also all your infrastructure as a holistic view within one software. So that is it for us today. Here we have the video, a promotional video of this particular project we worked on. This is a QR code if you would like to see a little bit more in details and hear us talk about it. And we're open for questions, either for Barrett or for myself.
Yeah, that's a good question. In total, start to end, it probably took us a month to get from the end of data collection to getting all the models. I would say, though, the time for a person to do that was probably maybe 40 to 60 hours. And those of you that have done processing, it really doesn't take much time to set it up, and then it's mostly just waiting for it to finish. We have like 3 rendering computers in our office, like the big gaming computers, and so we'll process on multiple computers, and so it goes pretty fast. And I think if we were to do it again, we could probably do it even faster, just because we have more horsepower now, and we just know better what we're doing now. Yeah, good question. So I kind of skipped over that. We use arrow points. I can't remember how many we ended up with at the end, but we went out, before we did the collection, we had our staff go out, lay out arrow points. They painted them on the bridge so that they were there for the whole data collection. And I can't remember, I think we have maybe 30 points that we collected. And we don't really need it to be geospatially correct for what we're doing, but it's so easy to use the arrow points to get that data, and it helps tie it together, and it also, I think, helps with verifying that the distances and things are correct. But we're not really trying to make it survey quality, although it probably ended up like that.
And I think you were saying that tourists are taking.
Yeah, well, that was the other. We put QR codes on like all the tops of the piers along the fascia, and it helps tie the top and the side and the bottom together. But we would often see people with their camera or their phones trying to check the QR codes to see what it linked to, but they don't link to anything. So they were disappointed.
So for the moment, the algorithm is only open crack unless the crack is going over the seal. So if there's a crack over the seal, it does detect it. But if it's just sealed, right now the detector has been trained not to count it as a crack. Now we are working on, I didn't mention it, but we are working on spalling, corrosion, seal, crack, and other cracking, efflorescence. Obviously in a bridge deck, efflorescence is not necessarily something that we're looking for, but yeah, we're working on having a catalog of more defects.
I think we ended up with 8 or 9 different segments. There's a couple that we felt like when we put the two together, it was easier to process. So we have a few that are 2 spans, but most are just those single spans. And we put the arrow points at the end of each span so that our models come together in the right place.
That is internal information, my dear. No, I would have talked to my AI scientists. We do have a workflow. We train them. Usually, I know we used PyTorch. I don't know if that in that project specifically we used it. We have an entire MLOps pipeline, and then we're also able to retrain every 3 weeks with new information. What file? But like the bridge in total?
That's a good question. I don't know. I haven't checked. But part of the reason maybe I haven't checked is because like even when you upload to iTwin, I mean it's pretty fast. So like we haven't had issues with people being able to load it. I mean I have to imagine the whole thing is like a terabyte by if you added everything up on the desktop. So I don't. Yeah, I don't think it's a terabyte on the cloud, but.
So that's part of the MLOps part where we do need traceability, which image was trained for which version, which weights were used for which version, which initial weights were used for which version. All of this is part of the MLOps system. Often when we first try AI/ML, we'll do it on the edge of the computer, and we'll just try it. And then as soon as you start retraining, this is where you see that you have to have this pipeline well defined to be able to have this traceability and go back with, especially like in our case, if we are able to do every 3 weeks, that means that some of it is automated and well defined. We can talk about it later, but yeah, there is proprietary information there. So it is possible within the iTwin Capture Modeler to train your own model on 2D images and have that output formatted in a way that iTwin Capture will be able to process it and reconstruct the 3D like we just did. I think HDR is working on that. I'm not quite sure how many people are doing that right now. Usually you do have to have your AI specialists and they have to know what they're doing. Raw imagery. It's on the 2D images, raw imagery. In this case, there was no LiDAR. So if you go into our pages of detectors, you will find all our detectors. Some are point cloud detectors, some are like 2D images, some are 3D as well.
All right, so what we're debating up here is if we come back a little early from the 45-minute break that's coming up and we end a little early, all those in favor say aye. The ayes have it. Come back at 3:45. Have a great break.
All the pictures. Do you want your slides up?